Well,
for it
yeah.
to
I
be
mean,
real.
I've heard him say a couple of times we witness the effect of gravity. I'll admit we see an effect. How do we know that that's gravity?
Well, that's the name they put on it, chocolate. I mean, it doesn't make sense what
Oh,
you just said.
I know. I want him to say it.
Yeah, exactly. I want to hear him say it.
Yes, that's the effect. We call it gravity. You can call it whatever you want, but that's an effect that we all can recognize.
So I can call the unicorn farts if I want.
You can call it whatever you want. It's like you can use
Cool.
any units of measure for things that we observe, right? We don't need to have the cause. We just need to know, here's the observation. Now, you want to get into cause.
False
that we can
equivalence
debate on.
fallacy.
Do I know?
The
do I
only
know
way
it's
you
caused
confirm
by
that is by
Benny's
scientific experiment, because you're proposing a cause and effect relationship, correct?
Okay, so we just don't need to know the cause.
Yes. Well, no, not necessarily. Depending on the experiment. If you want to do an experiment for gravity, we can do that.
Oh, we have already done that like 6 times. You're a star on my show with that, by the way. Do you want another go at it?
I'm up for it.
We're going to go with the kindergarten definition of scientific method. So we'll go
Kindergarten
with the
definition of the scientific method. What's that?
Let's just do it.
You want to do it?
Yeah, let's do it.
You're dependent. You're independent.
Watch
Your
this
control
one,
variable
Nathan.
scenario.
Hiya! I'm all that and a bag of chips. 1 second, please.
No worries.
How's
I've
it,
got a
Sharon?
project to work on.
Thank you, Emerald. You've been a good sport.
I've got to
as
run
always.
a lot of
No, you can't leave me.
heavy-duty
No,
program.
Emerald, you can't go.
Emerald.
All the
I'm sorry.
All the plants will die.
Hold on, let me just
All
thank
the
him.
plants will die.
Thank you, Emerald. You've been a good sport as always.
Hope to see you guys soon. Adios.
Yeah.
Till next time.
Later.
Okay.
Later.
Bye. Miss you already. All right, Zanuck. We got you on the screen again. This is like the 6th or 7th time. I'm loving this. Okay, we're going to do the same thing again. Natural phenomena. Observe, please.
Objects fall at 9.8 meters per second squared.
Yep, this is another one. Same one. What do I got here? Oh. All right. That is your dependent variable, correct?
Say a nice moment.
Independent variable, please. Say height. Because that's what you did the last time, please.
The dependent variable?
Independent.
I said, go ahead, Nathan.
Independent variable, please.
Oh, the independent variable. The mass of the object.
Mass of the object now.
Yes.
Okay, so the mass of the object, 1 second, please. Copy. So which gravity are we trying to elucidate here? Is it Einsteinian or Newtonian?
Newtonian.
Mass of the object causes... Damn, I got a lot of problems today. Causes... The mass of the object causes object fall at 9.8 meters per second squared. Go boom, boom. Paste.
Just summarize it just for Zanuck because he can't see it. So we've got a natural phenomena. Objects fall at 9.8 meters per second. Independent variable. Mass of the object. Alternative hypothesis. Mass of object causes object to fall at 9.8 meters per second squared. Is that correct so far?
Yeah, that'll work.
Say again, is that correct?
That's correct.
Okay, thank you.
Go boom, boom. 1 second, please. Mass of the object causes object fall go boom boom at 9.81 meters per second squared. Okay, before we get to the definition of mass, which is going to be loads of fun, go boom boom 9.81 per second.
Our dependent variable is going to be what again? What are you using for that?
Object falls at 9.81 meters per second squared. That was your observed phenomena.
Yeah, that's our test.
So
Observed phenom-
mass of the the mass of the object causes object fall go boom boom at 9.8 meters per second squared. Okay, helium balloon.
Okay.
The mass, whatever that may be, of the helium balloon doesn't fall down go boom boom at 9.81 meters per second squared.
In a vacuum, it does.
No, in a vacuum. Where's
What?
there a vacuum in nature?
Hold on. You had a
Okay,
you
go
had
ahead.
a
Anywhere there's
reasonable
a differential
phenomena.
pressure, there's a vacuum.
Hold on. We had a reasonable phenomena. Yeah. Now you've got this vacuum being introduced. You didn't mention it until now.
We have to have control variables, correct? You forgot that. You left that out.
Control? We don't live in a vacuum, sir. We're dealing with reality here. This is natural science. Nature abhors a vacuum. We don't have a vacuum.
You don't think vacuums exist? I can have a helium balloon that falls, sure.
Hold on. He said you don't think vacuums exist. Show me a natural.
Vacuums don't exist.
Show me a natural
Anytime there's a
vacuum.
differential pressure, there's a vacuum.
Show me one.
Measure the air density. Measure the air pressure at your feet.
Zanuck, is a helium balloon falling in a vacuum a natural observed phenomenon?
Depends on how you define natural.
Well, like an apple falling from a tree would be natural. You sat there and watched it and it fell.
Natural because man hasn't touched it, or natural because you can observe it?
Well, yeah.
If it's in a vacuum chamber, is it natural?
Sure.
We define natural
Oh, it is.
as here. I'll define it for you. That's a fair question. The natural world. I'm going to give you 1, 2, 3, 4 definitions from Merriam-Webster. All of the animals, plants, and other things existing in nature and not made or caused by people. Oxford dictionaries, existing or derived from nature, not made or caused by humankind. Vocabulary.com, natural, something that comes from nature rather than being man-made. And natural from Cambridge. From nature, not artificial or involving anything made or caused by people. Is that good?
So you can't use an helium balloon then because it's made by man.
Exactly.
No, that's not the effect.
Exactly. No. Come on. You are
no. Come on.
words. You got You have Merriam-Webster's dictionary in your back pocket. Yet you can't understand the difference between natural and natural phenomena. Go look up natural phenomena.
Natural and natural phenomenon. Yes, that's what anything made or caused by people.
Natural phenomena can't be caused by people. So a plane flying is not a natural phenomenon.
Okay, fine. He's got an objection with a helium balloon, saying, "Well, that's not natural." What about a plant?
Called engineering? No, it's not called
What about
engineering.
plant?
What's
Hold
a
on.
plane flying? That not a natural
Hold on a
phenomenon?
second. We'll just use helium then.
Is helium natural?
Yeah.
Yeah.
Have you seen it?
Yes, it is.
Helium? Show me some helium. Where do you get helium? How do you
It's a
get
gas.
helium?
It's a gas, Senate.
You ever seen helium?
Hold on.
You ever-
Hold on. We might have a new wingman for David Dallas. Do you deny gas?
Of course not.
Oh, so you don't deny that there's helium, that it's a real thing then?
How do you know it's real? Have you seen it?
Sorry, so you do deny helium?
Show me your proof. Show me your
Seems
proof.
like we got a helium denier. That's interesting.
It's helium, huh? Is that how it works?
So you
Show
deny
me
helium then?
I'm not denying. I'm asking you if you know helium. You say
Yeah,
it
I know
exists.
helium.
Yeah, it's on the periodic table.
Yeah.
Helium's a gas.
Goes up.
And
How do you know?
NASA
someone
is
told
the
you?
world's
Because you read it in a
foremost
book?
consumer of it.
Do you know
Because you read it in
something
a
I know-
book?
Do you know something I know specifically about helium? I know a little
How do
fact
you
about
get
it.
helium? Where's your helium from? Where does helium-
It definitely doesn't
Show
go
me where you get
down.
helium from.
Go boom boom.
You know where helium comes from?
I knew about helium when I was 5, and I had a birthday
Yeah,
party,
where
and
does
they
it
put
come from?
that stuff in
Where does it come-
balloons for
where
me.
does
It's
it
all
come
right.
from in nature?
It's all right. He's got an
Where does
objection
it
with
come from?
helium. Fine, no worries. What
Where
about?
does it come from? Where does your
Oh,
helium
hold
come
on.
from? In
It's
nature?
all right.
If we're gonna stay
I'll just
natural,
brush past it.
let's
I'm
stay
hand
natural,
waving it.
then.
Zanik,
Don't
I'm
change
giving you a
the playing
different
field.
example. Zanik. Right, so I used an apple
Where do you
from a
find
tree.
helium?
Zanik,
You know?
try and control yourself. Come on. I gave you an
I am.
example
Where do you
of a
find
natural
helium?
phenomenon.
Please help me
I'm gonna-
understand where you find
okay.
Is
helium.
it time for him to get kicked
Go on,
out again?
go on,
Because
race
he's
it.
not
he's
letting
gonna
me
piss-
talk.
He's gonna
Guys,
piss me off.
guys.
He's pissing me off as well. He's just not letting me talk. So Zanik, I gave an
Yeah.
example of an apple falling from a tree as the natural phenomenon you originally gave, right? However,
Right.
what about the tree itself? It goes up, right?
It can go down too.
No, it grows up.
Not always. Although the plant, the tree goes up, yes.
No, but you just said objects fall down at 9.8 meters per second, but this tree's going up.
Correct. So the mass that formed the apple, as I mentioned many times before,
It went up. Up. Yeah? I just grew some sunflowers. They're quite a substantial mass. And it didn't go down at 9.8
Of
meters
course.
per second. You're talking over me again. So do we need to count off the number of times the Fundy interrupts the demolition of his claimed phenomena? So the plants go up, like the helium.
Oh goodness. We're way off reservation.
Just one more thing, QE. So at the beginning of the last show, you brought up... No, end of the last show, you brought up a definition in regards to Newtonian mechanics.
Oh yeah, you want to see that again?
Yes, please. So the reason I ask
Okay.
is you asked Zanik to qualify which gravity he was qualifying scientifically, although he didn't manage that. And his answer was Newtonian.
You want to have some fun before that? What is the Newtonian law of gravity, Zanik?
big
Give it
G
to us.
mm divided by r squared.
1 second, we didn't hear you. You want to... 1 second, 1 second. Before you say that, 1 second, please. Okay, give us the Newtonian law of gravity.
The force equals G times M divided by r squared.
The force of G
Force of G.
equals what?
Mass times mass divided by r squared.
That's not Newton's law.
It's not.
No.
G
You-
M1 M2 divided by r squared. Yes.
No, that's not Newton's law. You want me to tell you?
It is.
Everyone in the audience
Force-
seeing it right now.
Equals gravity, big G, M divided
big
by r
G.
squared.
Okay, big G.
I
That's
said
not that's not Newton's law, son.
That is that by definition
No,
is Newton's
Newton's
law. Of course it
law. Newton's law is the force of gravity is proportional to m1 times m2 divided by the distance squared. You don't even know
I don't know
Newton's
what books you're
law.
looking at, but the universal law of gravitation is the force equals big G.
No, it's
times
not.
M- Oh, really?
No,
Let me
it's
give you a
not.
citation.
No, it is not. It is the force
I'll give you a
of
citation.
gravity is proportional to m1 times m2 over distance squared. I know you're wrong. You don't even know what the hell you're talking about. Where did Newton get
You help
big
me
G
explain.
from?
He calculated the gravitational constant.
No, he didn't.
Oh, okay.
No,
Well,
he didn't.
Tell me-
CV
tell me
Boys
what
calculated big G 207 friggin' years after the Principia was published, 167 years after Newton's death. What did he do? Was he did he contact him through some type of, I don't know, what's that called when you talk to dead people?
Seance.
Like, in a seance, did he channel him? You have no idea what you're talking about. This is Newton's equation. Big G wasn't even around. Haha, I just had to get you on that because I knew you'd fall into it. I'm going to pull this out for another show. Okay, back to Nathan's point. 1 second, Nathan.
Should we give you a
I didn't forget
citation?
about you. Citation?
Yeah. I'd like to drag this out a little bit, Zanik. Definitely. Yes, please.
Yeah, we need your citation for Newtonian law. Yeah. Go ahead and post it in live stream. We want to see it.
There you go.
Drum roll, please.
Oh, I'm in the wrong form. 1 second. Zanuck Universe today. They're wrong.
They're wrong. Okay, they're wrong, and you're right. Okay.
Yeah, I'm right. Where did G come from? Who calculated G? Big G.
You hear the question?
That's a good
They're
question,
wrong.
actually. I'm agree.
Hold on.
I agree. Hey,
Hold on.
I agree
Hold
with
on.
you.
Hold on.
It's a good
The
question.
question being asked, where did he get Big G? That's the question, Zanik.
Where did Newton get Big
No, I
G
think
from when it
it's a
wasn't
good
calculated? The Reverend John Michel and Cavendish didn't calculate it.
Have you ever heard of CV Boys?
No, I say that's a good question. I don't have the details on it. It's been a long time since I looked at this.
Oh, that's
Well,
cool.
you don't even know what you're talking about.
That's
You're
cool, John.
claiming
That's 'cause I don't have
Newtonian
the
law.
dates of when so I don't know what I'm talking about because I don't have the dates of when this equation was derived.
You
or how
don't
it was
even know
derived.
the law.
I just told you the law.
No, you were wrong.
Are you kidding me?
Well, are you talking about Newton's 3 laws of motion? I know
Oh
the 3 laws
my
of motion.
God.
Want to go over them?
Are we talking about Newton's 3 laws of motion, or are we talking about the universal law of gravitation?
Universal law of gravity.
There you
That's
go.
right. So why did you invoke his other laws of motion?
Red herring.
So I thought that's what you came back with. Did I
Red
hear
herring.
you agreeing correctly?
So let's just get this back on track. So
Right.
Where did he get the Big G from then? Doesn't come along for another, what was it, 207 years?
That's right.
Panic. Hello. Cavendish
You're right,
didn't calculate it, and it was. Wait a second, Zanuck. Cavendish pulled his non-experiment, him and Reverend John Michel, 111 years after Newton, after the publication of the Principia,
Correct.
and 71 years after Newton died. But Cavendish didn't calculate G. Big G. He didn't even calculate M.
He didn't calculate M. He didn't have a M in his equation.
No, he didn't. I have it right here from Indiana State University. Cavendish didn't calculate a numerical value for G or M. Do you know? Oh, we could pull that up. That's not a problem. Let's go down this trail. From the Michel Cavendish experiment. I love it. They titled it this. I claim ownership to this. Laurent Hodges, Department of Physics and Astronomy, Iowa State University. First, number 1, Cavendish did not determine either Big G or M. Everyone's looking at it. Do you want this citation? Let me put this citation in there for you. We'll call this Be Kind to Dumb Animal Week. You like that, Zanuck, don't you? You don't even know what you're talking about right from the get-go. Right from Jump Street. Nathan, do you want to stick on this?
I think you've rounded it out beautifully. We might have some remarks from Zanuck, but I'm hoping I can round out with you bringing up the reference that you gave to Anthony with the word replaced in it.
I'm headed down here right now. Okay, that is from Caltech. So let's pull this up. Give me a moment to find it.
No worries.
Caltech, here we go. Einstein also replaced the Newtonian law of motion. Let's make this bigger. I want everyone to see it out there, so there's no mistake. Where'd you go? That's 98 field equations. Where are you? Where are you? Einstein also replaced the Newtonian law of motion by the statement that free test particles move along geodesics, the shortest curves in space-time geometry.
What's the name of that geometry?
Pseudo-Riemannian force space.
And with that, I'm going to say a huge, massive, enormous thank you to all of you who've tuned in on the Nathan Oakley 1980 premiering stream for hopefully smashing the super chat, liking, commenting, sharing, subscribing, and all that good stuff. Of course, a massive thank you to all of today's debating panel for making this show possible. Be sure to check out nathanoakley.com and the Flat Earth Debate Forum to keep up to date with the community debate. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!